right, I made it on time. Okay, so this is the review I sent out on, I need my pen. There we go. All right, so that is the review I sent out. And I guess what we should do today is go through this. Yeah. I don't have any objections to that. Right. So I tried to make the review. Well, this is not the length of the review in terms of, I don't think I'm going to give you 5 log equations to solve. This is just to give you a variety. And then same with the exponential equations. I don't know if I'll give you that many. I just, again, wanted to give you kind of a sample to work through. So the test will be, the length of the test will be what I feel you should be able to finish in the hour, 15 minutes that we're here in class. So, all right, so let's go through this. The first question here is asking, or saying you put $6,400 into a simple interest account. It's important that I say simple interest account because that tells us that we can use the formula that I gave you in class, that shampoo formula. Your interest rate is given as 1.25, and it's asking how much will be in the account after 3 years. So let's go do that problem. Let me copy this. Just going to do this on a new page. All right, so what formula is that again? What's the formula for this that we need? A equals P times E raised to the R times T. So that's our shampoo formula for simple interest. We just need to identify the things that we're given here. So the $6,400, that's the amount that we put in the beginning. That's always going to be our P. Our interest rate is given to us as 1.25. That's going to be the R with one exception. What do we have to do? Convert it to a decimal first, right? So make sure that when you go and put this here, turn it into a decimal. Can't put it, if you put it in as 1.25, it's going to be wrong. And then last, it says how much will be there after 3 years. So 3 is our measurement of time. And in this formula, time is measured in years, all right? Okay, so that's it. We're just gonna plug and chug. So we've got 6,400 e to the 0.0125. That's our 1.25% converted to a decimal, and then times 3. And we'll need our calculator for the test. I'm not going to loan anybody a calculator. I think the lab will check out a calculator for you, but you have to leave your ID and stuff. No phones, right? Okay, so 6,400, we leave that alone right now. We need to figure out what E to that is. So I'm going to just do all of that on my calculator at one time. Since we've done this in class, this turns out to be 1.038211997. Now, when you're taking the test, don't round this to 1. Okay, don't round it to 1.03. Take at least 4 or 5 digits whenever you're doing it. But we're not going to round that part because that really will impact the accuracy of the answer. So take that, multiply by 6,400, and we get $6,644.50. I'll round up 56 cents. Okay, that's money, so I'll put a dollar sign in front of it. That's how much we would have after 3 years. Questions? What I didn't ask, but something I could ask. They're all right? Did you get something else or something? Okay. What I could ask is, in addition to this, how much will be in the account? I could ask you how much interest was earned. So that'd be asking you, how much money did you make? So how would you get that? Yeah, take this, subtract this, and that would give you how much interest you earn. How much did your money grow by, right? So I could ask that, just be ready for it. All right, so now we're going to graph some functions here. And we had spent so much time graphing functions in this class, right? And then, like the polynomials and the rationals and all those steps we had to learn and the tedious process. And then we got to exponential functions. And I told you these are the easy ones, right? So let's start with A first. To graph this, I wanted everyone to do the same thing, right? Everyone's going to make the same table. This is X, this is going to be f of X. And what numbers did I say I wanted you to plug in? -3, -2, -1, 0, 1, 2, and 3. So everyone's going to make a t-table using those numbers. And then you have to do this. This is going to be a lot of calculator work. 2.3, we got to raise it to the -3. 2.3, we got to raise it to the -2. 2.3, raise it to the -1, and so on and so forth. All right. So let me do that on my calculator. Get 2.3 raised to the -3. This first one comes out to be 0.082, very small number. And then we do 2.3 raised to the -2. Still a pretty small number, 0.189. And then 2.3 raised to the -1. Still small, but getting a little bit bigger, 0.434, something like that. Any number raised to the 0 is 1. And then 2.3 to the first power is 2.3. Square it, 5.29. And cube it, and we get 12.17 all around it. Okay, so that's what you should get, right? Now, as far as graphing it, I want you to pay attention to the fact that the base of the exponential function here is 2.3. And since it's bigger than 1, we should know that this is exponential growth, which answers part C, right? So when I say exponential growth, this means that we kind of know what the graph's going to look like. Don't write this down, but this is what exponential growth looks like. So we know our graph should look something like this. Notice that to the left, everything gets smaller and smaller and smaller, and then to the right, it's going to grow. So as I'm going to graph this, I'm keeping that in mind. So here comes the graph. On the x-axis, I know I'm going to have 0, 1, 2, and 3 to the right, and then just go the other way. Okay. Now, to figure out how tall your graph should be, what we want to do is we want to look at our y values, our outputs. And the biggest number we see here is 12.17. So I want to make sure my graph goes up 12. So maybe I'll count by 5s here, 5, 10, 15, however you want to do it. Just make sure that you don't, start with 1, 2, and then be, way up off your page, run out of room. Okay, and then what I recommend you do is graph the stuff that's easy, the positive numbers. Do that. So when you plug in 0, you get 1. So that's going to be down here somewhere. When you plug in 1, you get 2.3. So it goes up a little bit. When you plug in 2, you're a little bit above 5. And when you're at 3, you're at 12 something. So you don't have to be super precise on this. Just give me a feel for what's going on. And then the numbers to the left, what are we going to do about these? Because these are really tiny numbers. So what should we do? Should we actually try and graph them or just show the behavior? Let's just show the behavior. We know that this thing gets smaller and smaller, asymptotically approaching this dotted line, just like a rational function does. But on the right, we are going to grow and grow and grow. That's it. Questions on that? Okay, the other one, part B, the number that we're raising is 0.85. That's smaller than 1. So this is an example of what we called exponential decay. So that means the graph is going to look like this, but flipped over. So it's going to go down like that instead. It's going to go up on the left and down on the right for part B. So let's do part B real quick. So for part B, I make a table. X, -3, -2, -1, 0, 1, 2, 3. And remember, I'm taking 0.85, 0.85, raising it to the -3, 0.85, raising it to the -2, and so on and so forth. Go ahead and do that and get your answers here. Oh, oops. Wrong key here. Okay, I get 1.6263, I'm rounding. I get 1.38. Do y'all have any questions while I'm doing these? 1.18. Plug in 0 into any exponential function, you get 1. Plug in 1, you get 0.85. Plug in 2, you should get 0.72. And plug in 3, and you should get 0.61. So again, I'm going to use the fact that I know that this thing's going to go, the opposite of that. It's going to grow on the left and then go down on the right. So my X and Y axis here, my X axis is going to be labeled exactly like the one above. And then what I'm going to do is I'm actually going to start out, what is the biggest Y value I have here? What's the biggest number I have? 1.63. So I don't need to go up very far, do I? So what I'm going to do is way up here, I'm going to call that, let's say that's 2. Okay, so this would be 1 right there. So when I plug in -3, I get 1.6 something. So somewhere I'm just kind of ballparking that somewhere around there. When I plug in -2, I'm at 1.3, which is smaller than that, but still pretty high up there. And then I get 1.1, which is a little bit above 1. And then it goes to 1, right? 0, you plug in 0, you get 1. And then you plug in 1, you get 0.85, which is pretty far up here still. 0.72 and 0.6. So when you look at this, the way I graphed it, not very good. You can't really tell because of the number I gave you, 0.85, but this does behave like an exponential function. It is going up over here, okay? And this side, this is pretty bad drawing. This side is going down, right? I do have a horizontal asymptote over here. It is getting closer to that. It's just taking a little longer than the one above. The one above it, it went down to the x-axis really fast. This one doesn't, just the way it behaves. So that would be okay on the test. What I'm really concerned about is making sure you get your table right and that you have growth and decay correct. Questions? So far, pretty straightforward, right? Nothing surprising on the test. Everything's just a matter of coming in and executing the plan. Things start to get a little weird once we get to number 3, right? Oh. Because there's a lot of little things that we need to know how to do. All right. I do plan on putting a bonus question on the test. If I give you the test next week and there's not a bonus question, remind me and I'll put it on the board. I already know what it is, what it's going to be. All right, here we go. Solving exponential equations. So anytime we want to solve an exponential equation, that means we want to try and solve for the x, but the x is up in the exponent, right? And the way that we go after this is what? How do we attack these things? We bring in the natural log, right? The natural log is the tool we use. So I'm going to start with A. 5 raised to the x equals 125. By the way, you could do that just by looking. Some of you might be able to just tell me the answer without doing it. 5 raised to what number is 125? Well, the answer is 3. But let's act like we didn't know that, okay? And let's go through the procedure. So the procedure is you want to get that x out of the exponent, so you have to bring in the natural log on both sides of the equation. And the reason we do that is because of that property, that very important property of logs, that now what we can do is we can take whatever's up here and we can pop it out front. So what we're left with is the x in front times natural log of 5 equals natural log of 125. Now what? I'm trying to solve for x. Yeah, divide both sides by natural log of 5, because the natural log of 5 is just a number that we're going to get on our calculator. So we divide both sides by natural log 5. And you get on the left x, because those go away. And here, we're going to need our calculator, natural log of 125 over natural log of 5. So break out your calculators. Well, you should already have them out. And go ahead and make sure you can get this answer. 3. X is 3. Everybody get it? Questions? Okay, so let's look at B, part B. Okay, 3 to the x equals 8. This is another simple problem because it's just like the first one. The first one was just, 5 to the x is 125. We could look at that and say, oh yeah, the answer is 3 without doing any of this. But on this one, nobody here is going to tell me what x is. No one's going to be able to get that mentally. I mean, 3 to the first power is 3, so it's not 3. 3 squared is 9. It's not 9 because it's bigger. So it's somewhere between 1 and 9. But what is it? I couldn't tell you. I need my calculator. So I'm going to first start by taking the natural log on both sides. That then allows me to pull the x out front. So I get x times natural log 3 equals natural log 8. And again, divide both sides by natural log 3. So x is whatever natural log of 8 over natural log of 3 is. So we're going to get a decimal answer here. Natural log 8 divided by natural log 3 is approximately 1.893. Let's just round 3 decimal places. We good? Okay. All right, C. 3 to the x minus 4 plus 4 equals 10. 3 to the x minus 4 plus 4 equals 10. Okay, now we're getting into more complicated problems. Look, I'm probably not going to give you these first ones. This was just to get you in the review, just to kind of remind you, like, how do we go about logs, right? Like, how do we do, how do we solve exponential equations? This is more like it, okay? Because there's multiple ideas that you have to put together here. So we want to first isolate the term that has the number raised to the thing with x in it. We need to get that by itself. So first step would be to do what? Subtract 4, good, on both sides. So if I subtract 4 on both sides, I'm not going to show that step. I get 6 on the right side, right? So subtract 4. Now, at this point, I'm going to do the log because I've isolated the exponential term. So when I bring in the natural log on the left side and bring in the natural log on the right side, you remember, you always have to do it on both sides, okay? That will allow me to take everything that's up here, the entire expression x minus 4, and drop this out front. So be careful because this is, this is more than just x. Up here on these, we pulled the x out front. We're pulling the whole thing out front. And why that's important is because you have to put it in parentheses. So you have to have x minus 4 in front like this, times natural log 3 is still there, equals natural log 6. So we're trying to solve for x. We're first going to get rid of the natural log of 3, kind of like we did in the previous problems. We're going to divide both sides by natural log 3. It'll go away over here. And then what I'll be left with, I still have the x minus 4 on the left. And then equals, I have to do it on my calculator. Natural log 6 divided by natural log 3. I get 1.631, let's say. And then there's just one more step. Add 4, right? Add 4 and you got x by itself. So 5.1631. There we go. Questions there? D. 4 to the negative 2x plus 1 equals 10. 4 to the negative 2x plus 1 equals 10. Yes. Oh, I don't know why I put a 1 there. Wait a minute. Hold on. Oh, in front. Yeah, sorry. 631. Thank you. I don't want to move on. If you have a question, do you need me to clarify something? Danielle? Or oh, the natural log. Did you figure it out? Okay. All right. So here we go. Same sort of problem as we just had. We just want to isolate this piece right here. So we'll have to subtract 1 first. So 4 to the negative 2x equals 9. Then bring the natural log into both sides. Now I'll do a next line. Natural log 4 raised to the negative 2x equals natural log 9. Now I can pull the entire exponent, negative 2x, out to the front. I don't necessarily need that in parentheses this time because it's just one term. Negative 2x is not two things added or subtracted. So I can just put negative 2x times natural log 4 equals natural log 9. And I'm just going to play the same game we've been playing. I'm going to divide both sides by natural log 4. That will leave me with a negative 2x on the left. And then calculator time. 1.585. If you put 1.584, I'm not going to count it wrong. I mean, I'm not real particular about the rounding on this. The only time I care about decimals is when we do the shampoo formula, and there might be some. Yeah, well, there's another problem in here where we're going to use shampoo again. We need to make sure we're using as many decimals as possible. Okay, one more step. Divide by -2, right? Because you're trying to get that x by itself. So we will have to divide both sides by -2. Don't add 2, right? It's multiplication. You're trying to undo that. So you get x is equal to 1.585 divided by -2. You're going to get a negative answer, negative 0.793. Questions? All right, e to the 2x is 10. E to the 2x equals 10. All right, so we do have an exponential equation here, and the exponent is already isolated, right? There's nothing else over there. So we're free to bring in the natural log right now. So I'm going to bring in the natural log on the left and bring in the natural log on the right. That will allow me to take the power up top and drop it out front. So I have 2x times natural log e equals natural log 10. Now there's any questions? There's a couple of ways to go about this. The easy way is to realize what natural log of e is, because I told you all in class that's very special. Whenever you see natural log of e, what is it? 1. Now, if you try it on your calculator, you should get 1 as well, but I'm going to just use the fact that this turns into a 1, which means the left side is just 2x. And the right side is just natural log 10. So I'm going to do natural log of 10 on my calculator. So 2x equals 2.303-ish. And then divide by 2. So x is equal to 1.151 or 152, somewhere around there. Right, from here to here, all I did was divided by 2. All right, so the big thing on that problem is just to remember that natural log of e is 1. And that's going to be helpful on the last example here, F. For e to the x plus 1 minus 8 equals 8. For e to the x, what the hell was it? X plus 1 minus 8, okay. Plus 1 minus 8 equals 8. All right, this is the hardest problem out of these. Because the thing that you need to get before you can bring in the natural log, you have to get this right here by itself. And when I say this, I mean the e to the x plus 1, because the 4 is being multiplied in front. So what we're going to do is we're going to first take the 8, -8, we're going to move it to the other side, right? And once we do that, we will divide both sides by 4, and that should isolate that. So first step, add 8 to both sides. That should give you 16. Now divide both sides by 4. Okay. So from here to here, all I did was added 8 on both sides of the equation. Now I'm going to have e to the x plus 1, plus 1 equals 4. All I did from here to here was divided both sides by 4. And then I have it isolated. So I can bring in the natural log. Natural log of e to the x plus 1 equals natural log of 4. Pop the x plus 1 out front, put it in parentheses because it's 2 terms. I'll be left with natural log of e again, right? Once this x plus 1 comes out, natural log of e, that turns into a 1. And so I think I'm out of space. I'm going to just continue right up here. So I have x plus 1 on the left. That's all that's over there now. Equals natural log of 4, calculator time, 1.386-ish. Last step, subtract 1, both sides. So you should get 0.386. From here to here, all I did was minus 1 on both sides. There it is. Okay. Does this still seem reasonable for the test? Okay. All right, let's look at the next problem. So this problem is like the first problem on the test. It's similar, okay? The first problem on the test said, on the review, sorry, is if you put money into an account for a certain amount of time at a certain interest rate, it tells you how much you'll be there. That's an easy calculation because to do that, as we saw, all you had to do is plug everything into your calculator and you were fine, okay? There was no solving any sort of equation in that. But on this problem, it's still simple interest, but now we're asked to do something else, right? We plan to put money in, right? We're going to put money in to a simple interest account. So I know I'm going to be using the formula A equals P e to the RT, right? The 5,000 is how much I put in to start. So that will be P, right? They tell me my interest rate is 2.7%. That'll be R, right? But remember, you have to convert it to a decimal, right? And then the key to the problem is this: how long, right? How long will it take? Which means I need to know what T is, right? I want to know what the T is in the problem. What's the time that it takes to turn my money into $6,000? That's the amount I want at the end. So that's going to be my A. So let's replace everything. My equation should be 6,000 equals 5,000 e to the 0.027 t. And that's it. I need to solve that for t. So this is just like the problems we were just doing. It's exactly the same sort of thing, except we're using t instead of x, and it just looks a little bit different, but we want to isolate this piece. Let's get this by itself, right? Let's get that by itself so we can bring in the natural log. So we first have to get rid of the 5,000. So divide both sides by 5,000. So 6,000 divided by 5,000, oops, divided by 5,000. So I get 1.2 on the left equals e to the 0.027 t. All I did here from here to here is I divided both sides by 5,000, right? Now can I bring in the log? Yeah, right. So I'm going to take the natural log of 1.2 equals, and then natural log of e raised to the 0.027 t. On the right side, I can take the 0.027 t and I can drop it out in front of the log. I'll go ahead and on the left side, I'm going to do natural log of 1.2 on my calculator right now. This is 0.182 equals 0.027 t. Wait, where did the natural log of e go? It's 1, right? Remember, when I pulled that out, I really had next to this natural log of e, but that's really going to turn into a 1, so I don't even need to think about it. One more step. What do? Divide both sides by 0.027, right? So you should get 6.74 approximately is t. Here I divided both sides by 0.027. And that's my answer, but I need to interpret it. 6.74 what? Years, right? So 6.74 years. Almost 7 years. It'll take almost 7 years to turn my $5,000 into $6,000 if I have an interest rate of 2.7%. All right, moving right along. Log equations now. All right, here we go. Start with A. So these are logarithmic equations, right? So I think it's obvious that they're logarithmic equations because there's a log, right? But the x that we have appears in the log, right? So how do we solve these? This is different than what we were just doing. What do we do here? We use the loop, okay? So I showed y'all about this thing called the loop, right? So we're going to just rewrite this log in what we call its exponential form by taking whatever the base is here, 3, raising it to this power, and setting it equal to this. All right. So I'm just going to write that down. If I take 3 and I raise it to the second power, that should equal what's in the log, x. And hey, what do you know? 3 squared is 9. So your answer is 9. Straightforward on that one, yes? B, log base 2 of x plus 1. Now we have x plus 1 inside the log, but we're still going to do the same thing. We're going to do the loop. We're going to do 2 raised to that equals everything we see there. So I'm going to write 2 raised to the third power equals x plus 1. 2 to the third power is 2 times 2 times 2. That's 8 equals x plus 1. And now we have a nice little linear equation. Just subtract x on, I'm sorry, subtract x. Subtract 1 on both sides. Minus 1 minus 1. You get 7 equals x. I want to show you something, okay? Don't write this down necessarily, but what if someone did this? Common mistake. What did this student do that's wrong? They did the loop, right? But they did 2 times 3 and got 6. No, it's 2 raised to the third power. Okay, make sure you don't make that mistake during the test, because people will do it and they know it's wrong, but they're sitting there and they're stressed out and they do multiplication instead of exponent. All right, C. I'm going to erase that. So C, all right, 3 log base 5 of 2x plus 1 equals 9. So now we're getting more complicated, right? You want to do the loop, right? You want to do the loop because it's a log, but there's a problem. The log is not isolated. You've got a 3 out in front that's being multiplied. And so you cannot do the loop until your log is by itself. So we got to get rid of that 3. So any suggestions? Divide everything by 3. Okay, so divide both sides by 3. So we're going to divide the whole left side by 3, the whole right side by 3. All that happens on the left is the 3's go away, which still leaves you with the log base 5, 2x plus 1 equals 9 divided by 3 is 3. Now you can do the loop, right? Now you can. So 5 raised to the third, not 5 times 3. 5 raised to the third power equals the 2x plus 1. 5 cubed is 125 equals 2x plus 1. And now we have a nice little linear equation again. So we just start solving this, right? Subtract 1 on both sides. 124 equals 2x. Hey, what do you know? 62 goes in. X is 62. I told you in class, and I'll say it again here today. When you solve log equations, you're supposed to check your answers. But I also told you that I'm not going to give you any problems where you have to check your answers. That's for the 14 students, they have to really pay attention to that. Just as a little disclaimer, I want to make sure I say that. Okay, so D, let's try and do D here. D is, what the heck is that? Natural log, right? Natural log. We want to solve this equation. So the natural log is a log, and it is isolated, right? There's no number in front of it. It's by itself. And we need to do the loop. But in order to do the loop, you need to know the base. So what is the base of the natural log? Nope. That's the base of log, L-O-G. So if it's natural log, the base is E. All right. So even though it's not written there, we need to know that there's an E here. Okay. You need to know that for the test. And then you can do your loop. Do you remember I told you why we don't write the E there? Had to do with like typewriters and history, right? So I wish they would just have the E there, make life so much easier for me trying to explain it to you. Okay, so I'm doing the, what, E cubed equals 1 minus X. Okay, E cubed, well, sorry, I don't know what E cubed is, but my calculator does. So I'm gonna do E cubed. $20.09, let's say. 20.09 equals 1 minus X. Okay, don't mess this part up. Students will mess this up because I have 1 minus X, they'll do weird stuff. Just take your time, subtract 1 on both sides first, right? That'll get you a 19.09 equals negative X because it still has the negative X there. And then at this point, you can either say divide both sides by -1 or multiply both sides by -1. However you want to look at it, it has the same effect. It turns the left side into negative, and it turns the right side into positive X, which is what we're solving for. So our answer is negative 19.09. Questions? Okay, E is log 4x minus 8 equals 2. So again, we have a log, it's isolated, right? It's by itself. So we can do the loop, but we need to know the base. And when it's log, the base is 10. Okay, so we have to know that there's a 10 down here. And now we just do the loop. So 10 raised to the second power equals 4x minus 8. 10 squared is 100. And now I have a linear equation, so I can just start solving it. Add 8 to both sides. And then divide both sides by 4. What's that, 27? I made up these problems, so I'm surprised they're coming out. That's coming out to be a nice number. All right, how are we doing on time? Okay, 45 minutes in. Let's keep moving. Like I said, I don't intend that the test will necessarily be this long, but everything on here is fair game. So, all right, systems of equations. Let's just start with 6a. You want to solve this system of equations? This first one, I think we all have bought into elimination at this point, right? So what would y'all do? What would you do? Okay, you want to get rid of the x's. So how are you going to get rid of the x's? -2 on which equation, top or bottom? Bottom equation by -2. Yep. -2 on the bottom, distribute it through to each one of these and rewrite your new system of equations, which would be 2x minus 3y equals 9. We didn't touch the first equation. Second equation becomes -2x minus 8y equals 24. Just take your time through that because you don't want to mess up a sign on that, right? If you mess up one thing there, it's over. So we got that double checking. Yep, looks good. Now we add these down, right? We just add down and see what we get. So the x's go away, so we get nothing. And then minus, there's two negatives there together being added, so -11y equals 33. You've got to be kidding me. I made this problem up just mentally. I didn't expect that it was going to come out to be nice numbers. What now? Divide by -11 on both sides. Y is -3. Wow. I wasn't even trying to make it nice. Y equals -3. Okay, we know what y is. And to get x, what do? Plug it in where? Where? On the 24? Yeah, be careful there. -2 hit it. So what do we plug it into what? In any of them, right? So when you say bottom, which one? You mean the x plus 4y equals -12? You want to go into that one? Yeah, just remember, you can plug this y into anything you want. So we're choosing this one. And let's go ahead and plug it into that. So I'm going to have x plus 4 times y, but y we just said was -3. That must equal -12. Huh, interesting. We get x minus 12 equals -12. And then we add 12 to both sides. And we get x is equal to 0. That's okay. All right. X is equal to 0 is our solution. Remember what this means, right? Remember what this all means. If we were to go and graph these lines, right? We go to x equals 0, y equals -3. That point is where the two lines hit each other. Now, I did say pay attention though, because if you do this step, and remember, if you work this out and you get something that doesn't make sense, like 2 equals 4, what does that tell you? No solution, right? That the lines are parallel. And what if you get something like 2 equals 2? infinite solutions. So it's the same line. Just be prepared for that because, I mean, we did talk about that in class. So, all right, next one. So this one I did, I used fractions because you all love fractions so much that I figured I would give you one with fractions. Whoa, how do y'all want to do this one? Do you want to keep the fraction on the first equation and work with it the whole time? Or do you want to just kill off the fractions first before we do anything? It's up to you. See, you see fractions, y'all just shut down, right? I'm going to kill the fractions. Okay, I'm going to kill the fractions. So what I'm doing is I'm looking at the equation with the fraction in it. It's got a 2 down here. I'm going to try and get rid of the 2. So I'm going to multiply the entire equation by 2. 2 up here. So right now I'm not trying to eliminate x's and y's. All I'm trying to do is clear fractions out. So I distribute a 2 through here, and let's see what our new system would look like. So when I multiply that 2 times that negative 1/2 x, I should get just a negative x. Y'all understand what happened there? The 2 on the top and the 2 on the bottom cancel. You still have the negative though. And then you have plus 6y, because we doubled it, equals 2. And then the other side is x minus y equals 6. We didn't touch that one. Hey, look at this. We don't even have to do any more work. The x's are going to cancel. Got lucky. So I can just add down now. So if I add down, the x's go away. I'm left with 5y equals 8. So I have 5y equals 8. And I have to divide both sides by 5. Why is it doing that? 8 divided by 5, I'm going to get that as a decimal. 1.6. Is that what you said? 1.6. Okay, so we know what y is. Once we know what y is, we can go back and get x anywhere we want. I think the second equation here is probably good. Let's use that one because there's no fractions in there. So let's take our answer. X is 1.6 and plug it in there. 1.6 minus y equals 6. Pardon me? Oh yeah, I almost messed that up. Thank you. We solved for y, so I'm replacing y in the problem solving for x. Y minus 1.6, that would have been a disaster, equals 6. Right, replacing the y with 1.6. Add 1.6 to both sides, and you get 7.6. Yeah, we got it. X and y. These two lines do intersect somewhere. Questions? Okay, word problems. Number 7. Now, I did one of these, 2 of these in class. I don't remember. I did one of these in class, right? But I did it with an acid solution, not with a saline solution. So the one I did in class was mixing acid together to get a new acid. This is like salt waters together, same principle, same exact thing. So you had the one we did in class, then there was a homework one I asked you to do, right? And now I'm showing you one on a review. So that means I probably am going to give you a mixture problem like this. All right, so we need to mix a 5% saline mixture with a 30% saline mixture to get 12 gallons of a 10% saline mixture. So I drew some pictures. You don't have to draw pictures, but I'm going to draw pictures just to help me. So this is my 5% mixture. I'm going to add to that some 30% stuff. And when I finish, I need to finish with a 10%, and I need 12 gallons. I'm going to put 12G, okay? 12 gallons. What I don't know is how much of each to use. So I'm going to call the amount of this X and the amount of that Y. So X is equal to, just so I know, is the number of gallons of the 5%. And Y is equal to the number of gallons of the 30%. What do y'all think? Just what is your intuition telling you? Just if I'm mixing a 5% saline solution in a 30 and I need to get a 10, am I going to have more of the 5 or more of the 30? What do you think? If I need 12 gallons, you think I'm going to need more 5, right? What if we did half and half? What if we did 6 of each? I think that would probably be too strong. Like the percentage would be too high, right? Because 10% is closer to 5 than it is to 30. I don't know, I'm just trying to get you to think through this. All right. All right. So what is there any equation I can set up right now? Is there anything I know for sure? The number of gallons of the 5% and the number of gallons of the 30%. When I mix those together, how many gallons total do I need? 12. So that should be my first equation. I know that X plus Y has to be 12, right? The number of gallons of this one plus number of gallons of that one has to be the number of gallons of this one. The hard part is the second equation, which has to do with the concentrations of the salt. So it's basically, we're going to try and figure out how much salt is in each of these mixtures. So what did I tell you to do? To figure out the concentration of salt or acid. How do you get the concentration here, here, and here? You turn the percentage to a decimal and multiply it by what? How much of it you have. Convert that to a decimal, multiply it times how much you have. And set that equal to, this is a decimal, multiplied by how much you have. So I'm going to do that next equation in green. I'm going to take 0.05, that's 5%, times X, plus 0.30 times Y must equal 0.10 times 12. This is the salt concentration equation. This over here in blue is the amount that we have. The amount, this is our gallons. Two different ideas. This is how much total liquid we have together. This is the concentration of salt being put together. So that should give us our two equations. Let me write them down. We have a system. We have X plus Y equals 12. And then we have 0.05X plus 0.30Y equals, well, on that other one, I can multiply, it's 1.2. 0.1 times 1.2. 0.1 times 12 is 1.2. All right, one more step before we solve. What would you like to do? Let's get rid of the decimals. So to get rid of the decimals, I see that I'm going to have to move this over twice, right? This over twice. This I would only have to move once, but we need to do something that works for all of them. So I'm going to have to go twice for each of them. Twice, twice. So that'll get our final system. X plus Y equals 12. And then we have 5X plus what? 30Y equals 120. Okay, there's our system. I'm going to take a quick break. Why don't you finish, see if you can finish this out. Get your X's or Y's to cancel, solve the system. Give me. Feel like sharing? What'd you get? 2.4 and X is what? 9.6. Anybody agree? Yes, we have one agreement. Okay. All right. Sounds right. Because we have more of that 5% than we do the other one, right? Let's see if it's looks good. What I'm going to do is I'm just going to solve for one of them. So did you all multiply the top one by -5? Is that what y'all did? Okay. Here, here, here. This is a new system. -5x minus 5y equals -60. And then 5x plus 30y equals 120. The x's are going to cancel when we add down. We should get 25y equals 60. And dividing both sides, 60 divided by 25, 2.4? 2.4. Okay, this is right. And then you go plug that into one of the other equations, you get x. So what you should do here, I mean, really you should state the answer. Since it's a word problem, you should state the answer in terms of what they were asking, how much of each, right? So you would say something like 9.6 gallons of which one? Of the 5%, and then 2.4 gallons of the 30%. All right, that's what it would take. 9.6 gallons of the 5%, 2.4 gallons of the 30%, stir it up, you're gonna have 12 gallons of a 10% saline mixture. Oops. Sorry. I feel like I'm gonna sneeze. Okay. Next one, last one. Is this the last one on there? Tell y'all a quick story. When I first started teaching, right? Well, the first class I ever taught was at UTSA, and I was standing in the hallway waiting for the class to start. I was nervous as hell, you know. I was like standing there, like, and I walk in, I get up to the front, and I start handing out the syllabus. And the kid sitting in the front row, I hand him the syllabus, and he goes, "Are you the professor?" And I'm like, "Yeah." And he's like, "No fucking way." Right? I was 22, I think, when I taught my first class. I was 22 years old. So it was like, I understood he was like 18, right? So it was kind of odd. So the reason I'm telling you this is because in my college algebra classes, students back in the day used to ask me how old I was, right? How old are you? And I wouldn't tell them, but I would give them a system of 3 equations and 3 unknowns. Where we're doing a system of two unknowns, 2 equations and 2 unknowns. I would give them 3 equations and 3 unknowns. It would be something like this: Robert's age plus Jack's age minus 5 times Jill's age is this. And I would give you 3 pieces of information. And if they could solve it, they would know how old I was. But that would come later in the semester. All right, ready? If John's age plus Jill's age is 50, and John's age is 5 years older than twice Jill's age, that sounds stupid, then how old are John and Jill? All right, sorry, all right, it is what it is. All right, so we want to know John's age and Jill's age. And I use John and Jill so that you couldn't use letters like they're both J's, so you can't use J and, you know what I'm saying? Like if I said John and Mary, you could say J and M. I just tried to make it complicated. So let's establish what we're trying to do. Let's let X be equal to John's age, right? That sound good? Let's let y be equal to Jill's age. All right, so any equations we can start with? X plus y is 50, right? That's the first statement they give us. X plus y is 50. John's age plus Jill's age is 50. Okay, so that's our first equation. Now, the next equation, John's age is 5 years. It should just say 5 more than twice Jill's age. How could you write this as the second equation? 2y plus what? Equals x. So let's see if this makes sense. X is John's age, right? John's age is 5 years older than twice Jill's age. 5 more than twice Jill's age. Jill's age is y. So twice Jill's age plus 5 is what John is. Make sense? All right, we have 2 equations. We can set up a system, but remember when we do systems, we need like our x's and y's lined up. So what I'm going to do is I'm going to subtract 2y on both sides over here to make this look like 5 equals x minus 2y. And that way, when I set up my system, I can have x plus y equals 50. And the other one will be x minus 2y equals 5. And then once we're here, we just try and eliminate one of them. I'm going to go for the y's. And the reason I'm going for y's is because it's easy to kill the y's if I just hit everything with a 2 on top. You could do the x's if you wanted to. I'm doing the y's. My new system, 2x plus 2y is 100. And then x minus 2y equals 5. Add down. 3x, the y's are gone, equals 105. And that means x is what? What is it? 80? 35. 35. I thought you said 85. 35. X is 35. Okay. And then to get y, we go to any equation we want. I like this one up here. I like that one. I mean, you know the answer is 15, right? Because their ages add up to be 50, but I'm just going to solve it. Okay, x plus y, x is 35 plus y equals 50. Subtract 35 on both sides and you get 15. Okay. Finished in time. That's it. Plus a bonus question. That gives you a good idea of what to expect, yes? Any questions? Test is on Tuesday. Make sure you show up on time. Make sure you have your calculator. Make sure that you're not tired and hungover or something, right? All right. I'm going to stop this.